Hi everyone. Today, in fact, long pending activity will be performed and we are ready to show the today's activity of the transformer. We have mentioned earlier that we will be performing the demonstration of transformer in our future program, and that future program is today. So let us enjoy it. It's a very beautiful concept of electrical industry and electrical engineering and electrical science. If you remember the story of Michael Faraday, from that day the science develops till now and getting refined every moment, every day, every year, and so on. So the beauty of Faraday's laws of induction involves the principle, as you might know from your books. When there is a magnetic field and changing, then if you keep a coil nearby, you will be getting induced EMF at the end of the coil. So this is a very interesting concept. Now he showed, suppose you have a magnet and you have a coil nearby and you are moving the magnet in or out of the coil, and in that case you will be getting induced EMF which can be shown at least by a galvanometer. But today we are equipped with full practical activity for the commercial transformer action. As you see, I will request to show all the arrangements on this whiteboard. Here is the source. This is 24 volt alternating current. I will describe again why do we require alternating current. And thereafter a coil here with an iron assembly arrangement like this. I show you. There is a coil, means you might note there are two ends, and those two ends I show you towards you. These two ends are connected by wire to these 2 points, and these 2 points I will first show by multimeter that it provides almost 24 volt alternating current. So that's my first activity. I will show it. Please note it down. And the second activity I show you here now is like this. We are having another piece of coil supported by a iron core inside, and we have made the arrangement like this. You can remove the core iron. I have removed. Please check. I can insert. So this is the arrangement. Take a note. Everybody has to do, those who want to perform this experiment at home. So why did we have an arrangement like this? I will show it during the time of demonstration. Now my first duty is to measure the voltage of these 2 points, and please note that your multimeter will take a note of alternating current or voltage. We measure the voltage here, and please check, here is a V symbol. I show it towards you. Here is a V symbol with a sign of alternate current or alternate energy. What is that alternate? I will explain a little later on. But let me measure first for all of you. These are the 2 points. I put this energy on to this device so that I get 24 volt or something like that, near about alternating current. Please check. The reading shows 28.22. That means we are all sure that the energy provided to the coil is 28 volt alternating current because of this symbol I told you. Exactly, please note this symbol. Now I make it off, and further the meter function is not there, so I make it off. That means I have to show you that when we provide 24 volt alternating current to this coil, and these are the iron arrangements outside, I will show you at least one effect, that I have a piece of iron rod and I will show it that whenever I power it on, you will observe this particular rod will be attracted because of the magnetic attraction, and you can have a sound effect also, and that sound effect will be a humming effect. Please be ready to listen to that. You could see how that affects the magnetic field. I will do in this manner so that you can see that attracts with a sound. Suppose I attach it here, and then you can see this is having a sound of attraction and getting struck and sometimes falling down. So this is not important. I just wanted all of you to take a note that this electrical energy is converted to a similar type of magnetic energy in this iron core. But remember, this iron core is cut in between. So what I am showing now is very interesting. I keep this coil inside this gap like this, and then I will allow the alternating current to flow in the coil, and please observe nothing happens visually, but something happens internally. That I want to show it now. What happens internally? I keep this iron rod inside and take it out, and then I put it here directly in between these two rods, and all of you can see this LED, which was already there, was not getting sufficient energy to glow. This LED, is an electronic component that requires minimum 2.2 volt to operate. So where from this 2.2 volt is coming? This is totally separate. Another coil is there at a gap, and only connection is by magnetic power. So this magnetic power is playing an important role in this experiment, and the LED glows. For your observation, I take this rod out and I keep it here, and I have got another rod, you have already enjoyed it, and I keep it like this, and I just hold it and I support it, and you could see this also plays the similar role as before. And please observe, if I remove it, this is cut. If I insert it and place it both the arms, then the glow is, I think, the highest possible for that arrangement. That means highest voltage will be obtained in this coil if we touch both these ends. If you do not touch, see, this is the result. You are not touching both the ends. Now, what I do not touch, I take it that side, but I don't touch, even though slight energy is developing. And Gradually with my proximity, you will find it is the best arrangement. That means here we allow the magnetic field to pass through a loop. That means this is called a magnetic circuit. So if the magnetic circuit is complete, then maximum induction takes place as per Faraday's laws of induction. I hope this is very interesting and all of us have enjoyed this experiment. We using 24 volt alternating current from this device. Now somebody may ask, what is this device, sir? How do you get 24 volt here? You are using another wire which is connected to the source of 230 volt. This is same as this. How? The same arrangement is inbuilt here, compact. There are two coils, one above the other. One coil is fed with 230 volt alternating current, and the other coil which comes to this end produces 24 volt, 12 volt, 6 volt, 18 volt, 3 volt, whatever you like. So this is in accordance with Faraday's laws of electromagnetic induction. Now to confirm, I wind up. Inside this we do have two coils, one coil here and one coil here, having a lot of gap. Because of this gap we lose energy, we waste energy. But here in commercial transformer they don't give any space, void space. And another thing, you observe this metal, these are all soft iron heavy blocks, and they confine the magnetic field efficiently. And because of that efficiency, this transformer, suppose I use here, I get 8 ampere, but volt is 24 volt. But here, because of my this nature, gap, energy loss, even though I provide 24 volt here, I am getting here only 2 volt because of this loss. Iron loss, air loss, so many factors are there in electrical engineering. So if you study electrical engineering in future, you will understand how are the transformers designed. And for today it is enough. I hope you have enjoyed it. I have enjoyed too, because I have done, and my colleague with me. And you remember, my colleague with me is always with me, Mr. Shivashish Mishra, to support us, to take this snap and to reach it to you. Thank you all. Have a nice time, and we meet again in the next episode. Thank you. Meet next.